All right, welcome to the Explainer. So today we're diving into a really big question, one that's on a lot of people's minds. Can AI actually figure out the real world? I mean, do these systems we talk to every day truly get it? Or are they just, well, incredibly good at faking it? Like a parrot that can repeat sentences but has no idea what it's saying. So here's how we're going to break it down. We'll start with a quick reality check on AI, then get into the simulation problem, why they struggle. After that, we'll look at how we're building a bridge to reality, what happens when they step into our world, and finally, try to land on an answer. All right, first up, the AI reality check. Let's get real about what these models can do and maybe more importantly, what they can't do when rubber meets the road. You know, this comment from a Reddit user just absolutely hits the nail on the head. They said AI is so articulate, but super stupid at the same time. And that really captures the weird paradox, right? These things sound like geniuses, but their actual grasp on reality can be, well, shockingly flimsy. They're amazing simulators, but they aren't actually thinking. So check this out. This is a perfect example. A study from MIT and Harvard found that something like GPT-4 could give you flawless turn-by-turn directions for getting around New York City. Almost 100% accuracy. But, and this is the crazy part, when the researchers actually looked at the map the AI was using inside its own head, it was pure fantasy. Just a jumble of made-up streets that don't exist in the real world. Okay, and this is where it gets really telling. The researchers decided to throw a tiny wrench in the works. They closed just 1% of the streets in their test. Just 1%. And what happened? The AI's accuracy went from nearly perfect all the way down to 67%. Just like that. It shows you how brittle that internal map is. One little change it didn't expect, and the whole thing just falls apart. So, that leads us right to the heart of the matter, the simulation problem. Why? Why do these incredibly powerful systems break so easily when they bump into something they haven't seen before? Well, the most well-known issue is what we call hallucination. See, an LLM doesn't know that Paris is the capital of France. It's not looking up facts. It's just a prediction machine designed to figure out the most statistically likely word to come next in a sentence. Its only goal is to sound correct, to sound plausible. It's not trying to be correct. That's a huge difference. And this really gets to the core of it. LLMs are all about statistical learning. Think of it like learning a language by just listening to billions of conversations. You pick up the patterns, the flow, the vibe. But you don't necessarily understand the strict grammar rules. That's what classical symbolic AI does. It works with hard, verifiable logic. If A, then B. So LLMs are super flexible, which is great, but it also means they're, well, kind of unreliable. When they don't know the pattern, they'll just make one up. And that one core problem leads to this whole cascade of other issues, right? Their knowledge is frozen in time, so it gets out of date. They don't really have a long-term memory, so they'll forget what you talked about at the beginning of a long chat. They can be biased, they make up sources, you get the picture. And when you add all that up, you realize you can't really trust an LLM by itself for anything super important. Okay, so it's not all doom and gloom. How do we fix this? Well, this is the exciting part. Researchers are coming up with some really clever ways to connect these powerful language simulators to the actual, factual world. They're basically building a bridge to reality. The first big idea, our first pillar, isn't actually about changing the AI at all. It's about changing how we talk to it. So instead of just asking a question and hoping for the best, we can guide it. We can prompt it to think out loud, step by step, and basically force it to show its homework. Yeah, and you can see that evolution right here. It started with simple stuff, but now we have these really cool techniques. Chain of thought is like telling the AI to follow a single path of logic from A to B to C. But then you have something even cooler called tree of thought, where the AI can explore a bunch of different possible paths at the same time, kind of like a detective considering multiple suspects. It can then ditch the bad ideas and follow the most promising leads. So what this all means is that developers now have ways to make the AI's problem-solving a lot more structured. Chain of thought is great for straightforward problems, but it's a bit like a train on a track. If one part is wrong, the whole thing goes off the rails. Tree of thought is way more flexible. It's better for those really messy, complex problems where you need to weigh a bunch of different options. Now, the second pillar is a total game changer. What if, instead of just relying on its outdated internal memory, we could connect the LLM to a live, reliable source of facts? We're basically talking about giving it an external brain. And the way this works is through a technique called retrieval augmented generation, or RAG for short. It's pretty simple, really. You ask the AI a question. Before it answers, the system goes and looks up the relevant, up-to-date facts from a trusted database, like your company's internal documents or today's news. Then it feeds those facts to the AI along with your question. The result? The AI's answer is grounded in reality. It's basically the difference between asking me a trivia question and letting me guess versus letting me Google it first. The answer's going to be a lot better. Okay, our third pillar is maybe the most ambitious one yet. The idea here is to create a hybrid system, to take the incredible, flexible language skills of an LLM and pair them with the super rigorous logical powerhouse of old-school rule-based AI. And this approach is called neuro-symbolic AI. Think of it like a team. You've got the LLM, which is like this brilliant, empathetic communicator. It can understand all the nuance and sentiment when you're talking about, say, a movie you just saw. But then you have the symbolic engine, which is the logical, no-nonsense manager. It makes sure the conversation stays on track and follows a consistent set of rules. You get the creativity of one and the reliability of the other. It really is the best of both worlds. So you've done all this work. You've built an AI that's way better at reasoning and connected to facts. So what's the final exam? What's the ultimate test? Well, you give it a body. You let it step into our messy, chaotic physical world. And this is a whole field of research called embodied AI. The idea is to use these smarter, grounded large language models as the brain for a physical robot. This is where everything we've talked about, the smarter prompting, the external brain, gets put to the ultimate test. And this isn't just science fiction. It's already happening. There's a system called Elmer that plugs GPT-4 into a robot arm, using that same RAG technique to keep it grounded. This robot can do something complex, like the whole multi-step process of making a cup of coffee. And this is the important part. If something changes, like you move the coffee mug, it can adapt on the fly using its sensors. It's not just following a rigid script anymore. Which brings us all the way back to where we started. So, what's the answer? Can these large language models actually figure out the real world? Well, if we're talking about an LLM all by itself, the answer is a pretty clear no. Their core design just isn't built for that. They are incredible language simulators, amazing mimics, but they aren't true reasoners. Their internal picture of the world is just too fragile. But, and this is the big but, as a piece of a bigger puzzle, absolutely. They are becoming the conversational reasoning engine inside a new generation of AI. By using all those bridge-building techniques we talked about, we can connect them to reality, making them way more capable, way safer, and genuinely useful. And that really leaves us with one final, kind of mind-bending question to chew on. If an AI, a robot in your home or at your job, can act perfectly, if it can do what you ask it to do reliably and safely every single time, does it actually matter that it doesn't understand the world the same way a human does? I don't know the answer, but it's a question we're all going to have to grapple with as these AIs keep stepping out of the computer and into our world.